Hey Pre-Calc, today we're going to be talking about section 2.2, day 3, using U-Substitution. So if you're given a polynomial in standard form, you can figure out all of the roots by factoring. But sometimes you can't really factor nicely, because polynomials could have whatever for a degree. So we're going to practice that. So state the number of possible roots, and turning points. Then state the number of real zeros by factoring. Okay. So the possible real zeros, we learned this, I don't know, a while ago when we did, or I guess not a while ago, but a couple days ago in the video lesson. So the possible real zeros depend on the degree of the polynomial, so we do need a polynomial. I'll do g of x equals x to the fourth minus 3x squared minus 4. Okay, so possible real zeros. That is the degree, right? So there's 4 possible real zeros. And possible turning points. Is the degree minus 1, so there's 3 possible turning points. So if I wanted to graph this, or if I wanted to know what the real zeros were, I need to now factor it. So the first thing you want to do is set your function equal to 0. So I'm going to take my equation and do 0 equals x to the fourth minus 3x squared minus 4. Now if we're going to factor this, first thing is, can I factor anything out? And the answer is no, because they don't all have something in common. And it's really challenging. You guys know how to factor quadratics, but you don't know how to factor anything else. Or at least I haven't taught you. So what you can do next, the second step for U-substitution, is you're going to rewrite it with x squareds. So what that means is I'm going to replace this. How could I rewrite this with an x squared? So if I had x squared, I want this to be to the fourth, so I'm just going to square it, right? Because this is equivalent to x to the fourth. And then this is already x squared. Okay, now is where we use U-substitution. So we are going to let u equal x squared. And you do need to actually write that down. So I'll write it off on the side. Let u equal x squared. So that means everywhere I see an x squared, I'm going to put the letter u. So this will become u and then squared. So I'm just replacing this. Minus 3u minus 4. Now this looks a heck of a lot easier to factor. So that's what we do next. We just factor like we know. And we should be good at it at this point in pre-calculus. So what multiplies to negative 4 and adds to negative 3. There's not even an a value here, so it's even easier. So this will be u minus 4 times u plus 1. Right, because negative 4 times 1 is negative 4, and negative 4 plus 1 is negative 3. And then now we have our factors. So the next step is to substitute your x squared back into your equation. And our factors will be x squared minus 4 times x squared plus 1. Now it's not always going to be, u is not always going to be x squared, it could be bigger, but that's what made this look like a quadratic. So you're going to rewrite it so that you know that this exponent will be 2. So then it's easy to factor. Okay, and we're almost done, so now we need to continue factoring, because we can factor this more. So step 6 is factor completely. So this can be factored because it's a difference of squares. You learned that in Algebra 2 and I believe Algebra 1. So this is x plus 2 times x minus 2. Now you can't factor this anymore to get real zeros because I did ask for real zeros. So my real zeros, if I use the zero product property, be 0 equals x plus 2, 0 equals x minus 2. So we get negative 2 and positive 2. So these are our real zeros. Now we are going to be doing complex numbers later, so I'm just going to review this. But this can actually factor to be x plus I times x minus I, because I times I, right, that would give us the positive 1, but then we would have imaginary roots. So that's that. We'll practice this more in class.